everyone, so this is homework problem, homework set number 1, problem 37. An opera singer in a convertible sings a note at 600 Hz while cruising down the highway at 90 kilometers per hour. What is the frequency heard by a person sitting beside the road in front of a car, a person on the ground behind the car? So the first thing I would do is box any given numbers that I see it because it makes it easier for me to identify the knowns and unknown. And the next thing I would do is figure out what type of problem this is. So because it's asking you what's the frequency heard by a person standing beside the road or a person on the ground behind a car while the car is moving, you know that this is going to probably be a Doppler effect problem. So, and you can pull out your equations, your 4 different equations that you can use. So I would also now then write the unknowns and knowns given to you by the problem. So for knowns, you know that a singer is singing at a note of 600 Hz. So you would know that this is probably going to be your F naught if you're looking at your Doppler equations. Right here, right here, right here, right here, F naught. Your F naught is going to be 600 Hz. Now, you also know that the velocity of the car is at 90 kilometers per hour. So you know that the velocity of the source, velocity of the source is 90 kilometers per hour. And you also know that the speed of the sound is 343 meters per second. So now the next thing you would do is figure what type of problem this is. So you know that since this is the Doppler effect, there's 4 equations, but you're trying to figure out which of the 4 equations they are. And because in part A, part A is asking you a person standing beside the road in front of the car. So let's draw out the scenario. So a person is standing on the side of the road in front of the car. So you have your car. And you know that your car is moving. The source. So because the person is standing and you want to know what the person is hearing for the frequency, you're going to use the Doppler effect for an approaching source. You don't want to use observer approaching the source because the observer is not moving. So you do not want to use these 2 equations, and you pick one of these 2. And because the car is going at the velocity of the source going towards the observer, you'd want to use the Doppler effect for the approaching source formula, which is going to be F plus is equal to F naught over 1 minus Vs over V. And now you probably noticed that your velocity of the source is not in SI units. So you would want to convert that to SI units because you're going to end up dividing with the velocity. So it would make your life easier if you convert it to SI units. So velocity of the source is 90 kilometers per hour. And to convert it, you want to end up with meters per second. So to do that, you're going to have to cross out kilometers and hour. So let's cross out kilometer first. So if you want to cross out kilometer, you have to put kilometer in the bottom. And you know that 1 kilometer is equal to 1,000 meter. So with that, kilometer can be crossed out. And now you also want to have seconds and cross out hour. And you know that in 1 hour, there's 3,600 seconds. So this is just the number that I just memorized because in the past few problems or past courses, they usually want conversions from hour to seconds. So it will be useful for you to memorize this conversion. So if you use the calculator, you know 90 times 1,000 divided by 3,600, and you end up with 25 meters per second. So knowing you have your velocity of the source, you have your velocity of sound, and you have your frequency of the source, you can find the frequency of the observer now. So you just want to plug in the formula, 600 hertz over 1 minus velocity of the source, 25 meter per second over 343 meter per second. And I usually write the units because it's a way to double check your units and answers. So meter per second cross out, and you have hertz now. So 25 minus 3, or 25 divided by 343, and you get 0.073. And now you can just plug everything in the calculator. 600 divided by, you want to put parentheses in the calculator because these two go together, 1 minus 0.073, and you end up with 647.2 hertz. However, you want to make sure that you have the correct suffix, and based on the given, based on your knowns, you have 3 suffix here, 3 suffix here, and you have 2 suffix here, and or this 2 suffix, and 2 suffix is the least, like yours. You choose the suffix that have the less amount of suffix, so you'll have 2 suffix and 2 suffix. So you're going to want to, from 647 hertz, you want to do 2 suffix. So you look at this and you end up, because this is a bigger number, you end up 650 hertz, and that's going to be your answer for A. Now for B, the question is asking a person on the ground behind the car. So let's draw the scenario. You have your car going and a person. Okay, they can lay down. Oh no. Okay, a person is on the ground behind the car, and the car is traveling at the velocity of the source, 25 meter per second. And now you go back to your equation, and because the car is traveling away from the observer, you would use the Doppler effect for the receding source, which is this formula, F minus equals F naught over 1 plus Vs over V. You probably noticed that the only difference between these two equations are the plus and minus. So your given is 600 hertz over 1 plus 25 over 343 meter per second cross out. You will have 601 plus 0.073, and you can plug it into your calculator. 600 divided by, don't forget to add the parentheses, 1 plus 0.073, and you get 559 hertz. And again, you have two sig figs, so you'd want to look at that, and you end up with 560 hertz as your answer. And that is how you do homework 1, problem 37. Thank you.